All right, good morning. How are you? Today we are going to be taking a look at 7.2 separation techniques. So separation techniques are how to separate out mixtures. And the first way that we use to separate out mixtures is a pretty simple one called filtration. So to get us started though, I am going to draw a beaker and make ourselves a little solution here. So in that beaker, we have some water. And some salt, and you can't see the salt because these two, water and salt, are a homogeneous or homogeneous solution. Again, that means that they're mixed evenly and generally can't see the dissolved particle in a homogeneous solution. On the bottom, however, I am going to put some sand. And this is a heterogeneous mixture. So I can't call it a solution. Solution is reserved for homogeneous. So heterogeneous, heterogeneous, however you prefer to say it. This is just a mixture. These sand particles have fallen to the bottom. It's not mixed evenly. You can see the particles. There we go. So back to our filtration. How filtration works, and you've probably already done it at some point in your life. So you have a funnel. The bottom of that funnel is your beaker, whatever you're using to collect the material. So we're going to have the water dripping through there. And then don't forget, you have to put a piece of filter paper into the funnel. The funnel by itself doesn't do anything. So the funnel by itself doesn't do anything. We need to line it with a filter paper. And then you pour your substance in there, and the heterogeneous mixture, the heterogeneous part that's not mixed evenly, gets caught in the funnel. So we catch our sand. Now, unfortunately, it doesn't work for homogeneous solutions. Our salt water is still going to be salt water. We're still going to end up with salt down here. That filter paper probably isn't going to take much salt out, but it will take the sand out. So it works really well for heterogeneous mixtures. All right, so that brings us to our next separation technique. Let's say we really wanted to get that salt out of that water. Well, a pretty simple one. Is crystallization / evaporation. And that's pretty simple. Just take a beaker and you apply some flame, some heat. Yeah, hopefully it's a little bit like a flame to you. And what happens is that the water is going to vaporize. We had the heat, the water vaporizes, it evaporizes and boils off. And now we're left with just the salt, which is going to then crystallize. That's where the name crystallization comes from. So our salt is going to recrystallize down here, and we left with just salt. The problem is doesn't keep the water. So this is good if you just want to keep the salt, but the water is going to fly away. So if we want to keep the water part as well, we need to use one of my absolute favorites, distillation. Distillation. All right, so this one is kind of complex drawing here. I'm going to have to do it by pencil to make sure I get it more accurate. Generally use a round bottom flask. So there's our round bottom flask. And just like before, we're going to add heat to it. So we put our solution of salt water into the round bottom flask. Add some flame, add some fire, get the heat going. But this time, up on top of the round bottom flask, we have what we call a condensing tube, which is generally a kind of a big circle. And the condensing tube is going to catch the gas, so the gas can't just fly away. So here's a round bottom flask. Here's our condensing bubble, and connected to that is a really cool device called a condensing tube. All right, so a condensing tube is basically two tubes. We have this inner tube and we have this outer tube. It's a piece of glassware usually, and you have these two tubes and you connect hoses to these outlets here. And so the water comes in, cold water generally, and it just circles around the inner tube, and then it leaves right here. And so the water that you're running through does not mix with the inner tube. Again, that inner tube is kind of separate. But what we have happening, again, is we have our solution. And as we start to boil it, we're going to collect the salt just like we were able to before. But this time, in addition to collecting the salt, as that water vaporizes, so it's really hot up here, but then it runs through this cold water chamber and it condenses back to liquid. And then we just have to collect it in our beaker. There's our beaker down at the bottom. And the water just kind of pours off. And voila. So now our salt would be left. Our salt would be left here. Our water would boil off. Salt is not going to boil at 100 degrees, but water will. So we just heat it to 100 degrees. The salt stays. The water boils off. The water is collected and brought back. And we can collect our water. So this is really a cool technique, in my opinion. Allows us to separate two liquids even. This is actually the process for making liquor. Liquor is large times water, alcohol, and water. Well, alcohol boils away at a lower temperature than water does. So what we need to do is find that temperature. I think it's about 90 degrees for alcohol. and 100 degrees for water, Celsius. And so if we can find that happy medium where we're between 90 degrees and 100 degrees, the alcohol will boil off. The water is left behind, and then you can collect the alcohol. And that's how spirits are made. So it's a really pretty cool process. The water gets left behind. It's not 100 degrees. The alcohol evaporates. It is above its boiling point, and you're just able to collect it. I guess the bad part is this is expensive equipment. But again, it's a really cool process. I don't know if you've ever been to Tennessee, if you've ever been to the plants there, but they call them stills. They make their whiskey in stills or moonshiners. Moonshiners oftentimes have a still, and that's where that word still comes from, distillation. That's what they're doing. They're boiling off the alcohol and then collecting it, and the water gets left behind. So this would be our way. Hey, if you have salt water and you want to get water to drink, you'd have to distill it. Also, you should be aware, hopefully by this point, that tap water is not perfectly pure. The water that comes out of our faucets at home has iron in it, it has all kinds of chemicals in it. What we use in the chemical laboratory here is distilled water. We don't want all of those different things that come with regular water. So what we're doing is, again, we're boiling our tap water. Everything that comes with the tap water gets left behind. Only the water boils away. We collect the boiled water, and that's our distilled water. It's, in theory, perfectly pure water, which is much better for us to use in the lab. As far as what you drink the faucet water, drink the tap water. Nothing harmful about that. All right, finally, we have chromatography. With chromatography, there are a lot of different types. Gas chromatography, paper chromatography, gel electrophoresis. I don't know if you guys remember doing that one in biology class last year. But gel electrophoresis is very similar to the process of chromatography. So chromatography, doesn't matter which one you're using, they'll kind of work the same. They separate substances based on how fast they're traveling through some sort of medium. And you can change your medium based on how you want to separate things. So for gas chromatography, large molecules travel faster than small molecules. So if you heat things up, make them both gases and let them travel through a pipe, that's usually what gas chromatography is, long coiled pipe. Well, the smaller molecules will come out first and the bigger molecules later, so we can separate things out. With paper chromatography, you may have done this before. You can do it with just a simple coffee filter if you want. Just put that into your liquid substance and the different particles move up the substance, like capillary action, at different speeds. And you're able to separate it out and see what you have. All right, so these are best used for analysis and not actually acquiring separated materials. So the other ones we looked at we were acquiring the liquid when we did distillation, and the solid for that matter. When we did crystallization on the page before, we were acquiring the solid, the salt particle. When we did filtration, we were acquiring whatever it was we were filtering out. When we do chromatography, we're usually not going to acquire anything. We're not going to be left with a liquid. We're not going to be left with a solid. We're just trying to do some analysis. We're trying to figure out what's in our sample. Here's a piece of paper. And again, you might dip that into a substance. Kind of let it soak for a little bit. This would be paper chromatography. And then come back and take a look. You might have a red band, and because this is purple, we'll say there's also a blue band. So blue and red make yellow, and then we'll say make a statement then, something like purple substance. So we dipped our filter paper into. So purple substance has both red and blue parts. So again, more of an analysis. We're seeing what's in it. We're not necessarily separating out our substance. We're just seeing what's in it with chromatography. All right, so there is our separation techniques. We discussed 4 of them. You see a few of them on your homework this evening. And then real quick, just because I really had nowhere better to put it, physical properties describe a substance without changing it. You can observe the color of something without changing it. The size of something you observe without changing it. The texture, these are physical properties. Chemical properties describe how easily or not easily for that matter, a material reacts. So things like this would be like flammability. How easy does it catch on fire? We often call that combustibility in chemistry. So things combust when they catch on fire. So how easy is something flammable? How easy to catch on fire? That's a chemical property. Corrosiveness is a chemical property. So oftentimes talk about an acid being corrosive, it's changing the material it's around. So how easily that thing gets changed, that material gets changed, is a chemical property. All right, so it's kind of didn't really fit in, but I had to put them here, had to put them somewhere. So there you go. There is your 7.2 notes, and we'll see you next time.